Hello everybody and welcome back to part 2 on section 16b, increasing and decreasing functions. So let's do some examples. If I have a function like this, 2x cubed plus 3x squared minus 36x plus 5, and I want to find the intervals of increase and decrease, first I need to figure out where are my maxes and mins. Okay, where am I changing from increasing to decreasing or vice versa? So I'm going to start by finding the derivative, and I'm going to set it equal to 0. Okay. So taking the derivative of this function, I get 6x squared plus 6x minus 36. And if I set it equal to 0, I'll find the points where the slope of the tangent is 0, and therefore points that are turning points. Okay, your book calls them turning points. They're also local max or min points. Okay, at this point they will be. So I set it equal to 0, and I find two turning points. When x is negative 3, the slope of the tangent is equal to 0, and when x is 2, the slope of the tangent is equal to 0. So now I know that something interesting is happening at those points. Now I'm going to set up a sign diagram, and you're going to see the completed sign diagram, but I'm going to walk you through it. So it starts with drawing a number line. And in our number line, we put our endpoints. In this case, this is a continuous function for all values of x. So the endpoints are negative infinity and positive infinity. And then along this number line, I'm going to put my 2 points of interest, my turning points, negative 3 and 2. And then I'm going to decide, I'm going to figure out what is the value of my derivative. So if I pick a point that is less than negative 3, that's in this interval, it could be negative 4, it could be negative 10, it could be negative 100, and I plug it into my derivative, okay, am I going to get a positive or negative value? Well, I could plug it into the derivative up here, but it's probably easier to think of plugging it into the factored form. If I plug it into the factored form, then I have, say I picked negative 4, I would have a positive value for 6, negative 4 plus 3 would give me a negative value here, and negative 4 minus 2 would give me a negative value here. So I would have a negative times a positive, which would overall give me a positive result. Okay, so, and it doesn't matter if I picked negative 4 or negative 10. If I picked negative 10, I'd still get a negative result here, and multiply them together to get overall a positive. Then I'm going to pick an answer, and if it's a positive, before I get here, if it's a positive value for the derivative, it doesn't matter what the number is. If it's positive, I know that my function's increasing. So this is telling me the sign of my derivative. This is telling me what it tells me about my function. Then I'm going to fill in the next part of my sign diagram. I'm going to pick a number between negative 3 and 2. The easiest number to pick is always 0. If I go back to my derivative, this factor is positive. This factor will also be positive because 0 plus 3 is positive. And 0 minus 2 will be negative. So I'll have a positive times a negative, giving me an overall negative result. And if my derivative is negative, we saw from our investigation that the function must be decreasing between those points. Finally, I'm going to pick a number that's between 2 and positive infinity. It could be 3, it could be 5, it could be 100, doesn't matter. I'm going to pick 3 for ease of calculation. If I go back to my derivative, the 6 will always be positive. If I plug in 3 here, I'll get a positive value. And if I plug in 3 here, I'll get a positive value. So I'll have a positive times a positive times a positive, which will overall give me a positive derivative and therefore tell me that my function is increasing. Now, I like this kind of a diagram. Sometimes I draw little arrows because it helps me think about the shape of the function. So increasing, I might write the word, but I prefer to draw an arrow and an arrow and an arrow because I can sort of kind of make a dotted line and connect them together and get an idea of what the shape of this function is without doing too much work. Okay? I also know it's flat here and here, so that's why those are flat. So we can say that the function is increasing between when x is less than negative 3 and greater than 2, and it's decreasing when x is between negative 3 and 2, and we have that, we're not going to use the greater than or equal sign, just the less than signs. All right, thank you. Continue to the next video.